Hello and welcome to episode 5 of the Qualiverse. I'm Jim Maltese and today we are going to be talking about display sizes. So how big should your displays be? This is a seemingly simple question, but answering it gets difficult quickly. We used to base the answer simply on task level and furthest viewer in the room. Then we based the answer on how large text would be on the screen. And most recently, we based it on how large elements were on the screen, the elements that we needed to perceive relative to the screen size. And I think all these different methods have their benefits and shortcomings. However, in the end, it comes down to the user's needs. So let's explore these different methods and perhaps come up with a new take to best meet our needs. It all started with the 4-6-8 rule, and depending on what task you expected to do in the room, the display height could be determined simply by dividing the distance to the furthest viewer, the person furthest away from the screen, by a task level. So we could divide the furthest viewer by 4 if we had to do analytical viewing of medical images or topographical maps or engineering drawings. We could divide the furthest viewer distance by 6 if we were talking about basic viewing of typical text-based documents or presentations, spreadsheets, etc. Or we could divide the furthest viewer by 8 for passive viewing of moving images or digital signage or something less critical. So for most conference room applications, we simply divided the distance to the furthest viewer, again, the furthest seat away from the screen, by 6 to get the proper display height. Users would hopefully be able to comfortably view text, documents, spreadsheets, or presentations. And it was a beautiful, easy to use, repeatable calculation that worked great until it didn't. You know, the 4-6-8 rule worked well with resolutions of 800 by 600 or 1024 by 768, but then people started getting all crazy with resolutions like 1920 by 1080 or 1384 by 2160, which is 4K, and now all of a sudden text height on the screen was reduced by 30 to 70%. And if you think about it, if you've got a 55-inch display, right, and it's 800 by 600, the pixels are going to be larger than if you have a 4K display. And so if we're talking about 12-point font on a 800 by 600 resolution image, they're going to be beefy. But now all of a sudden we've got the same 12-point font on a 4K image. And instead of taking up 10 out of 600 pixels, it's taking up 10 out of 2,000 pixels. So the text height gets smaller and smaller and smaller. And I'm sure you see that on your screens. As you get the 4K screens, you keep the whatever presentation software or spreadsheet software. And when you have those higher resolutions, the text gets harder to read because you're fitting more on that screen. There's a lot more pixel to use. But if you keep the font the same, the text is going to be much smaller. And that became harder to use, right? So users were used to signing into the computer from the head of the table when we had those smaller resolutions, 800 by 600, 1024 by 768. They could log into the computer from the head of the table without any issues. As soon as we get to those higher resolutions, now all of a sudden they have to squint a little bit because they can't see. And what happens if you think you're entering your username, so you type it in and then you enter your password, but you didn't press the tab right or something, and now all of a sudden you showed the entire room your password because you can't see. You can't discern the text on the screen. So once the text size for these higher resolutions was drastically reduced, they had to move to the middle or the foot of the table to get closer to the screen. That's the only way they'd be able to see what they were typing in. Something had to change in the way we calculated screen sizes. So enter the 150-to-1 rule. And this guideline said that the furthest viewer should be no more than 150 times the size of the text on the screen. It seems like a lot, but it's really not. So, this was really, it came from a subjective test of thousands of people. In the 50s, I believe, they took older users into account that had poor eyesight. So they really wanted to come up with a general guideline that would work for the majority of users and be able to provide a great viewing experience for like I said, the majority of the users. So The rule took into account the image resolution and font size being used during presentation. So as an example, let's say we have some resolution at some font size, the text on that screen will be 1 inch high. Okay, so if we have a screen with a resolution and a screen size is going to be 1 inch high, so the furthest viewer should be less than 150 inches away to be able to comfortably read that text. That's about 12.5 feet. So this led to some larger displays than we were used to, but keep in mind the testing took into account not only being able to differentiate an E from a C, but you had to comfortably be able to read the text on the screen. You know, we wanted to account for people who are going to be sitting in meetings for 2 hours, who are going to be looking at a large amount of text on the screen. So it's not just being able to resolve the text, it's being able to comfortably consume that text. So we wanted to account for that experience without inducing incredible amounts of eye strain and fatigue on the users. That's the whole point of it. And so they came up with this 150-to-1 rule. Designers could simply back engineer the equation to find out the display size for a given desired font size, resolution, and furthest viewer. And this worked well since the designer had a lot of variables to play with. They had display height, they had preferred resolution, and they had font size. So if the owner didn't like the price tag of a large display, we could still provide comfortable viewing experiences by adjusting the preferred resolution or the font size. For example, if a large display didn't fit in the room or the budget, it was recommended to use a lower resolution to make the text a little bit bigger, or a larger font size, obviously, to make the text a little bit bigger, to maintain the required text size to furthest viewer ratio, that comfortable reading experience. So designing for what had to be read on the screen made a ton of sense. So much sense, in fact, that it inspired the idea of focusing on what needed to be discerned on the screen as the driving force of choosing a screen size. So it might not always be text, right? And so enter the display image size for 2D content in audiovisual system standard from Avixa, lovingly referred to as Discus for short. Instead of focusing on text height as the 150-to-1 rule did, Discus posited that we should focus on whatever it is we need to see or understand on the screen. And whatever it is, whatever these things were, why don't we call them elements, and then use these elements to determine how large a screen should be. So if we need to read text on the screen, the element becomes the text. If we need to perceive individual lines in an engineering drawing, the element becomes the line of pixels. And this was a game changer. This was so exciting. Like I love the idea of finally basing screen size on what people need to do on the screen. It was I fell in love with the standard. So screen sizes could now be determined by element height on a given screen or percent element height on an unknown screen size to determine how large it should be, right? It's a great solution. So if an element takes up 2% of the pixels on a screen size, we can design for that. If a different element takes up 4% of the pixels, so it's going to be a little bit bigger, we can get away with a smaller display because the element takes up a larger percentage of the screen height. It's a bigger thing that we're trying to understand. We can get away with a smaller screen. It made total sense. But the problem with Discus is it recommends some uncomfortably large displays for large rooms. As an example, let's say we need a huddle room that is used to review spreadsheets. That's people come in and they look at their spreadsheets to review numbers, countings, what have you. 468 rule recommends a 55-inch display, 28-inch screen height for a furthest viewer that is 14 feet away from the screen. So pretty typical huddle room, small conference room. Nothing crazy. So 14 feet furthest viewer, we need a 55-inch display for the 468 room. Now, assuming a 1080p source, I'm not even going into 4K, assuming a 1080p source with the default Microsoft 11-point font, right? I just open up Excel or whatever spreadsheet I'm using and it defaults to 11-point font. The element for this use case is a lowercase e, right? Using uppercase would be cheating. I need to be able to comfortably read lowercase letters. So a lowercase e takes up 6 pixels of the 1080 vertical pixels I have in a 1080p screen. So 6 out of 1080 is a 0.5% element height. Using discus with a furthest viewer of 14 feet and that 0.5% element height, discus says we need a 24 foot, not inch, foot, a 24-foot screen that is also 14 feet tall. Obviously, this is not going to work in most huddle rooms, and in fact, it probably physically can't fit in most huddle rooms. It's a thing. So as a result of this quirkiness, and funnily enough, most designers have adopted discus because it's the industry standard, but they've adjusted their percent element height to be 2% or 3% or 4%, which just so happens to align with the 4-6-8 rule, back where we started. So old habits die hard, I guess. But it provided displays that people were used to buying, and you have a certain size room, you're used to seeing a certain size display. It might not be based on science, it might not be based on experience, like a user experience, but it's what we're used to seeing. So it's a challenge. It's challenging. And just, for your information, a 3% element height on a 1080p screen means that the minimum font size that should be used for presentation materials should be more than 48 points. 48-point font is the minimum font size for a 1080p screen for a 3% element height system. And so that's a difficult ask for most users when using presentation software like PowerPoint, let alone spreadsheets. Could you imagine doing spreadsheets in 48-point font? It's just not going to happen. So how should we determine display sizes? This is where we started. This is what we need to figure out. Do we keep the 4-6-8 rule, right? And do we kind of use discus but fudge some of the percent element heights that we recommend to kind of go back to the 4-6-8 rule where people are used to and they're happy? Well, they're happy buying, they're happy what it looks like, but they're not happy using it because they can't read the screen, right? They have to squint to type things into the computer. My recommendation is to have the users decide. Base the decision on their human experience. Ask the representative user, it's an average everything, average build, average eyesight, average everything, to pull up the typical material that they're going to use in these rooms on their screen at home, not even in the office. Pull up the typical material on their home desktop. Use their typical resolution, use their typical font size, whatever they want to see on the screen that they're going to put in this huddle room. Pull it up at home. Let's do all this calculations and all this exploration at home. Then ask them to move their chair back until they can no longer comfortably read or discern the elements on the screen. So once they get about here, I'm having a little bit of trouble reading what's on the screen, right? And so now I take this measurement and I've got my furthest viewer. Measure how far they are from the screen at that time, and that's the furthest viewer. And now we've created, based on that furthest viewer limit, a user-centered screen size standard. So I can proofread this document. I wrote this Qualiverse article. I can comfortably read it. I can comfortably proofread it. I'm looking at the entire document from about 50 inches away, 50 inches away. And so that'll be my furthest viewer. And the image size of this window is about 12 inches. So therefore, my user-centered screen size standard is that the furthest viewer should be less than 4.2 times 50 divided by 12. The furthest viewer should be less than 4.2 times the image height away. In our 14-foot huddle room furthest viewer example we had from before, this would result in a 75-inch display to satisfy my needs so that I can enter text from the head of the table. This is certainly larger than the 55-inch display recommended by the 4-6-8 rule, but way more reasonable than the 24-foot, 288-inch screen recommended by Discus. When we base our design decisions on the human experience of the users in these spaces, it may be easier to justify than basing them on nebulous rules or standards. And sure, this may result in display sizes larger than what you're used to, but it's based on science, and we won't have users squinting as they attempt to enter their usernames and passwords. And that's what we want, right? Easy to see and consume visual experiences for our users. So thank you for stopping by episode 5 of the Qualiverse. Please like, comment, and subscribe below. And have an AV day.